OPAMP configuration. In term, open loop indicates that no feedback in any form is fed to the input from the output. When connected in the open loop, the OPAMP functions are very high gain amplifier. There are of three open loop configuration of OPAMP, namely differential amplifier, inverting amplifier and non-inverting amplifier. The above classification is made based on the number of input used and the terminal to which the input is applied. The OPAMP amplifies both AC and DC input signal. Thus, the input signal can be either AC or DC voltage. Open loop differential amplifier. You can see in the diagram, in this configuration, the inputs are applied to the inverting and non-inverting input terminal of the OPAMP, and it implies the difference between two input voltages. The input voltage are represented by VI1, VI2. The source resistance RI1, RI2 are negligibly small in comparison with the high input resistance offered by the OPAMP, and thus the voltage drop across these source resistance is assumed to be 0. The formula can be given by V0 is equal to A of VI1 minus VI2. Inverting amplifier. In this configuration, the input signal is applied to the inverting input of an OPAMP and non-inverting input terminal is grounded. You can see in the diagram here, the non-inverting terminal is grounded, inverting terminal is given to an input. So hence it is called as inverting amplifier. The output will be 180-degree phase shift with respect to the input. VO is given by minus AV1. So non-inverting amplifier. The input signal is applied to the non-inverting amplifier. The input terminal of an OPAMP and the inverting input terminal is connected to the ground. So the input signal is amplified by the open loop gain and the output is in phase with the input signal. Let me write the diagram for this. If you are giving this input, the output will be amplified version, but it will be in the in phase. OPAMP and its application. OPAMP are used in a summer. In the summer there are of two types: inverting, non-inverting, voltage follower, integrator and a differentiator. So inverting summing amplifier, you can see here the inputs what we are giving is three inputs: V1, V2, V3. Okay, resistor R1, R2, R3. RF is the feedback resistor here. So ground terminal, you can see the ground terminal here. So the current which is flowing across R1 is I1, R2 is I2, R3 is I3. The current flowing across RF is IF. The inverting summing amplifier. It combines or adds a multiple input to produce an inverting single output. So need one resistor per input and single feedback resistor. The external component determines the gain. The output voltage is the algebraic sum of all the input voltages. The summing point at the virtual earth input. You can see the diagram here. Inverting summing amplifier. IF is equal to I1 plus I2 plus I3. That is given by, as it is inverting, you will get minus I. So V1 by R1 plus V2 by R2 plus V3 by R3. So here it is given by Rn, it is fine. Inverting equation is given by Vout is equal to minus Rf by Rin into Vin. So inverting summing amplifier produces the negative of the sum of its input, indicating phase inversion. Inverting summing amplifier. Input can be AC or DC. Summing point connected to an inverting input produces a phase shift output. Magnitude of phase shift is 180 degree. Unity gain amplifier. You can see R1, R2, R3 is equal to RF. So V1, V2, V3 are the input. So V output is equal to minus of V1 plus V2 plus V3. This is called as unity gain summing amplifier. So coming into a summing amplifier, we have taken an example here. By using the formula, we will find out the gain. A1 is equal to 10 kilo ohm divided by 1 kilo ohm, that is minus 10. A2 10 kilo ohm by 2 kilo ohm minus 5. V out is equal to A1 into V1 plus A2 into V2. So V out is equal to minus 45 millivolt. Coming into a non-inverting summing amplifier. It uses a non-inverting input of an operational amplifier which will produce the positive sum in phase of its input voltage. The input applied to the non-inverting terminal requires a negative feedback, and the gain achieved by feeding back some portion of the output to the inverting terminal. You can look at the diagram of the non-inverting summing amplifier here. R1 and R2 are the two input. V1 and V2 are given as an input to it. So with respect to R1 and R2, so output you can see feedback is RA. So AV is given by 1 plus RA divided by RB. So looking at the formula, IR1 plus IR2 is equal to 0 by KCL. No current can flow into the OPAMP output terminal as input impedance is very high. Therefore, V1 by R1 minus of V plus R1 plus V2 minus R2 minus V divided by R2 is equal to 0. So if we make two input resistance equal in value, R1 is equal to R2 is equal to R, then it is given by V is equal to V1 plus V2 divided by 2 thus. So gain voltage of non-inverting summing amplifier is given by AV is equal to V out by V in, that is given by 1 plus RA divided by RB. So final output voltage is given by 1 plus RA divided by RB into V1 plus V2 divided by 2.